Hello everyone, welcome to Vishesh Educational Videos. In this video, I am explaining one of the IPCs of Unix system programming, that is inter-process communication. Inter-process communication means how a two processes can communicate with each other using a intermediate file. So FIFO is one of the IPC techniques, right? I am going to explain that FIFO in this video. If you are not subscribed to my channel, please subscribe to my channel. To get the notification of my new videos, please click the bell icon, and please don't forget to like the video, and please don't forget to share the video with your friends. So let me begin the explanation of FIFO. So FIFO, as I told, it is mainly used as a interface between two processes. If one process wants to communicate with another process, it can use FIFO, right? So pipes are also mainly used for IPC. If you want to know more about pipes, the video is in the playlist Unix system programming. You can please refer that, right? So FIFO is also called as named pipes, right? So FIFO is mainly used to communicate, mainly used between the processes to communicate with each other, right? So pipe is also used for that purpose only, but the difference between a pipe and a FIFOs are, so FIFO can be used between the unrelated processes. That means in a pipes, right, only the processes that are related, that means only the parent and child can exchange information with each other. Only the process that having the common ancestor can exchange information with each other. That is, in simple words, only parent and child can exchange information in pipes. But in FIFOs, even if the processes are not related also, that means unrelated processes can exchange data. That's why FIFOs are sometimes called as named pipes. Why named pipe means we can use that names, right, to exchange the information between the processes. Using the names only, I can identify the different processes, even if they are not related also. That's why sometimes FIFOs are also called as named pipes, right? And also one more important thing, FIFO is also type of a file. FIFO is also type of a file. If you want to check whether your file is a FIFO or not, you can use the macro s_is_FIFO. If you use this macro, it will it will return a status whether your file is a FIFO file or not, right? So, and one more important thing, creating a FIFO is similar to creating a file, right? The path name for FIFO, right, exists in the file system because FIFO is also file. That's why, right? So how you can create a FIFO? To create a FIFO, you have a command mkfifo. So you can use mkfifo command to create the FIFO file, right? And the arguments are path name and the mode. We will discuss this mode and path name, right, later. So this function mkfifo returns 0 if it is a success and 1 on error. Okay, so in simple words, you can create a FIFO using the mkfifo command, right? The mode we will discuss. The mode in the simple way, in the simple words, I will explain the mode. So mode, mainly you can open FIFO for read mode or write mode or read write mode. For open also we can use the same mode values, read mode, write mode, read write mode. For FIFOs also we can use the same mode argument, right? And also whatever the rules that applies for the user and group ownership, all those rules that applies for FIFO also same. For example, user permissions, read permissions, user write, user others, group write, group read, group others, those type of permissions applies to FIFO also, where it is right, it is same for open, same for all the files, right? So once we have used mkfifo to create a FIFO, we can open it using the open, right? You can create a FIFO using mkfifo, but if you want to open it, you can use open function to open the FIFO. And also whatever the file functions are there, like close, read, write, all those functions applies to FIFO also. All those function will work with the FIFOs also, not on only regular files or what different files. No, along with regular files, these functions will work with the FIFOs also, right? And one more important thing, very important thing, when we open a FIFO, the non-blocking flag, we use non-blocking flag, right? Based on that we can decide what right effects that can take place in a FIFO. For example, see, in the normal case, that if a non-block is not specified in FIFO, open for read-only blocks until some other process opens the FIFO for writing. So normally it is open for only read only until some other process open the FIFO for writing. Similarly, in open for write only blocks until some other process open the FIFO for reading, right? So you can either if in the normal case you can open only for read purpose, or you can open either for write purpose until right other process read or write. Okay, if non-block is specified, it is not a normal case. In open for read only returns immediately, but in open for write only returns -1 with error number set to enx IO. That means non-block is specified, you can read, but write will not be set immediately, right? Write will be returned to -1 if no process has the FIFO open for reading. The condition is yes, you can open the FIFO, but no other process can open for reading. Then only this process can open the FIFO for reading, and write returns -1. And one more important thing, as with the pipe, we write to a FIFO that no process has opened for reading, the signal SIG pipe is generated, right? In the same way as pipe, if we write to FIFO that no process has opened for reading, the signal SIG pipe signal is generated, right? If no process has opened for reading. Next, when the last writer for FIFO closes, yes, where the writer is closed, the last writer for the FIFO closed, the FIFO, an end of a file is generated for the reader of the FIFO. That means you have to tell that the end of the file is reached, right, when the last writer for a FIFO closes, right? You have to tell that to the reader. Okay, so it is common to have multiple writers for a given FIFO. That means we can have multiple writers for a given FIFO. Multiple writers can write to the FIFO simultaneously. That is possible, right? This means that we have to worry about atomic writes. Yeah, that is very important. Atomic writes means if someone makes changes, the changes should reflect on all the other places also, right? Suppose consider my value is 10. Assume that one process is reading that value 10. When that process is reading, I can't change the value of 10 to other value, right? That is atomic write, because a value, whatever the process that is going to read, that should not be corrupted. Okay, right? The same value should be the same value should be read by all the processes, right? So that atomic writes, that means atomic write means simultaneously when the processors are trying to write to the FIFO, they have to follow some synchronization. When they follow some synchronization, no corrupt writes can happen, right? Hope you're understanding, guys. Suppose if you have any doubts, please post your doubts in the comment section, right? So what way synchronization means, what we can do, we can if we don't allow the writes from the multiple processes, right, to be interleaved, then we can avoid this, right? Interleaving, if you avoid, you can avoid this, right? And also, as with the pipe, here also in a FIFO, the pipe buffer specifies the maximum amount of data that can be written to FIFO. How much of data you can return, how much of data that can be written to the FIFO, that is already that is specified in a constant called pipe underscore buffer. So this is the constant, right? So there are two uses for FIFOs. What are those? FIFOs are used by shell commands to pass data from one shell pipeline to another without creating intermediate temporary files. If you want to pass data from one shell pipeline to another shell pipeline, you can use FIFO. Without creating intermediate temporary files, you can pass the data from one shell pipeline to another shell pipeline. I will explain that now. And also FIFOs are used as a render service points in client server application to pass data between the clients and the servers. Yes, using the FIFO you can pass the data between the clients and the server, right? I will explain these two cases now. So example, so here I'm using a FIFO to duplicate the output streams. That is the first case. Without creating the intermediate file, you can pass data from one shell to another shell. How we can do this means, so FIFOs can be used to duplicate an output stream in a series of shell commands. If you want to duplicate an output stream, so you can do that using a FIFO. So here if you duplicate an output stream in a shell command, so here as I told, you don't need any intermediate disk. You don't need to write the data to an intermediate disk, right? So but only disadvantage in pipe also we can avoid the intermediate disks, but the only disadvantage in pipe means pipes can be used for only connections between the processes that are linear, but in FIFO but FIFO is a name, right? Even if it is not linear also, you can it can be used for non-linear connections. Non-linear means, right, different FIFOs can be, right, used without any linearity, because they have a name, because FIFOs are named pipes, that's why, right? So for example, so to explain this, how a FIFO is going to duplicate the output streams, so consider a procedure that needs to process a filtered input stream twice. It has to process the input stream twice. How it's going to do that? For example, you can see here input file here, right? So it is filtering the input stream from the program 1 twice. How it is? Here with a FIFO and the Unix program T is a program copies its standard input to both its standard output and to the file named on the command line. First you have to know what is a T. T is just a program. T is a program. It copies its standard input, to its standard output also. Along with that, it's going to copy that input to the file named on the command line. You can see here how we are doing this. See, we are creating, right? You can see here, right? So I will explain this procedure in a detailed way. See here how it's going to do that, how it's going to write the input to its standard output and the file named on the command line. See, what I am going to do is, see, program 1 is what? It's a T. See, we create a FIFO. First we create a FIFO, then start the program 3 reading from the FIFO. We created a FIFO. We started the program 3 by reading from the FIFO. We then start a program 1, and what I will do means I will use the T. You know that, right? T can send its input to the standard output and also to the command, right? C. So I will use C to send its input to the FIFO and also the program 2. See, T, what it is doing? It is sending the standard input to its output also, that is FIFO, its standard output, and also it is sending the data to the other command line also. See, right? So T can copy standard input to both its standard output and to the file named on its command line. It can, so here what it is doing, it is sending the input to the FIFO, that is standard output, and also it is sending the input to the another program, that is program 2. So in this way I am avoiding the intermediate file. I am sending the input to the two duplicate outputs. See what I am doing here? So I am duplicating the output streams. See, so same thing is used by program 3 also, same data can be used by program 2 also. How I achieved that? using a T program. First I created the FIFO. I start the program 3 by reading the content of the FIFO. That means input first passed to the FIFO, then the same input is passed to the program 2 also by the T. Hope you are understanding, guys. What I did here, same input is passed for FIFO also, it is passed for program 2 also by using a T. T is a program that can send the input to the standard output, also input to the file that is specified. Hope you are understanding, guys. Suppose if you have any doubts, please post your doubts in the comment section, right? Next, second example is the client server communication using a FIFO. So another use of FIFO is what? To send the data between the client and a server. For example, if you have server that is contacted by the numerous client, each client can write its request to a well-known FIFO, right? Well-known FIFO means that the server creates. Well-known means FIFO, the path name of the FIFO is known to all the clients, right? All the clients know the path name of the FIFO where it is actually. That needs to contact the server. See, it is a very simple diagram. See here, it's a very simple. If a server is contacted by numerous clients, see, numerous clients can contact the server, right? They can send the requests. Numerous client can contact the server by sending the request. Each client can write its request to FIFO. Each client will write its request to FIFO. See, client is not directly sending the request to the server. Client, what they are doing, they are writing the request to the FIFO. Well-known FIFO means all the clients know the address of this FIFO. Then only they can write the request, right? That's why client is writing the request to the FIFO, right? Right? Then what? Server is going to read that request from the FIFO. In this way, client and server are communicating with each other. So getting, guys, client writes the request to the FIFO, then the server reads the request from the FIFO. Client knows the FIFO address. All the clients know the FIFO address. That's why it is a well-known FIFO. All the clients know the address of a FIFO. Hope you are understanding, guys, right? So, and one more important thing, since there are multiple writers for the FIFO, the request sent by the clients to the server need to be less than 5 buffer bytes in the size. So that's why, yeah, when you're sending the request, you should be very careful that the size of the whatever the size of the request, that size of the request needs to be less than the size of the FIFO. That's the right. You can't the size of the write can't be more than the size of the FIFO, right? Getting. And one more important thing, what is the disadvantage of making the request less than the pipe buffer? That means this prevents any interleaving of client rights. You can't interleaving, right? You can't interleave the rights of the clients. The problem in using FIFOs for this type of client server communication is how to send replies back from server to each client. Obviously, yes, here I am talking about how a client is going to send the request to the server by using the FIFO, but how a server is going to send back the reply to the client, each client, because server has to take the request. Yes, server can easily take the request, but how a server is going to find out which request is from which client? How a server is going to know that? That is the problem in this arrangement, right? So a single FIFO can't be used, as the client would never know when to read the response versus response for other clients. Obviously, clients will get confused, right? So how to overcome this, right? How to overcome this? One solution is for each client to send its process ID with the request. Obviously, I have to do in such a way that client has to send its process ID with a request. Then server can identify the client and it can send the processed output to the particular client by seeing the particular process ID. Hope you are understanding. Then the server creates a unique FIFO for each client using a path name based on the client process ID. What I am trying to say is, here server can create a separate FIFO for each client. Here in this arrangement only one single FIFO was used by the all the clients, but here what is going to tell means, instead of using a single FIFO, you can maintain, server can maintain separate FIFOs for separate clients. Along with that, each client should send the process IDs also with the request. Thereby server can identify which request is from which client. Hope you are understanding, guys. For example, see, for example, I will show this arrangement here. See, so see, server what is doing, it is creating a FIFO, client specific FIFO. See, client specific FIFO. Hope you are understanding what it is. It's a simple. So instead of maintaining a single FIFO, server is creating a separate client specific FIFOs for separate clients. Server is creating that separate FIFOs for separate clients. You can see, right? Thereby server can also read the replies, and also it can write the replies. See, obviously process ID will be there along with the request. Obviously that's why server can easily find out each client, and it can read also, it can write also. Hope you're understanding, right? Right? Hope you're understanding. Next, so here the process ID will also be there along with your request. That's why this is the name. So, right, this is, what is this? This XXXX is assumed that it is a process ID. See, this is the common format for every client, but here this XXXX contain the separate process IDs for separate clients. Hope you're understanding, guys. Right, thereby server and client can easily communicate. Right? Right? And but one problem here is even the server, right, can't tell whether the client crashes or not. Right? Right? So this causes the client specific FIFOs to be left in the file system. The server also must catch the sick pipe, since it's possible for a client to send a request and terminate before reading the response. So here server is for server it is impossible to tell whether the client crashed or not. That's why what we can do means we can allow the client to send a request and terminate before reading the response, right? And also it will leave the client specific FIFO with one writer and no reader, obviously, right? So in simple words, right, I can allow the client to send a request and terminate before reading the response, right? And also with the arrangement shown in figure, if the server opens its well-known FIFO, right, each time the number of clients goes from 1 to 0, the server will read an end of the file on the FIFO, right? Hope you're understanding what I'm trying to say is, with arrangement, whatever the arrangement shown here, if a server tries to open the well-known FIFO, right, that is for read only. If the server, yes, because server can read, right, so read only, right, each time the number of clients goes from 1 to 0, the server read an end of a file on the FIFO. So to prevent this, what we can do, the common trick is just to have the server open its well-known FIFO for read write. So what we can do, instead of only reading, we can open the FIFO for read write also. That is the, right, we can open the well-known FIFO for both the cases, read also, write also. Then, right, what we can do, so we can avoid this problem that each time the number of clients goes from 1 to 0, the server will read an end of the file on the FIFO, right? Like we can avoid this by opening the FIFO for read also, write also. That's it, guys. Hope you understood the concept. Suppose if you have any doubts, please post your doubts in the comment section. Thank you for watching the video.